Okay, we're going to look at solving and graphing inequalities. Uh, we'll go forward first with the basic inequalities, which you solve just like an equation. You get your x or whatever your variable is by itself, and then we'll go further and show compound inequalities where you have and or involved, which will make sense once we cover a few. All right, solving and graphing inequalities with one variable. And a little reminder here, don't forget if you multiply or divide by a negative number, you got to flip that inequality sign. If it's less than, you'd have to flip that over to greater than. Only if you multiply or divide by a negative. So let's take a look at the first problem. We want to get x by itself, so we add 5. We have x is less than 7. So just write the numbers in the approximate vicinity of 7. You don't have to start at 0 and write a whole bunch of numbers. Now something to note, if your problem is, I'll make a note of this down here, if it's less than or greater than, you're going to put an open circle. Less than or greater than gives you you mark an open circle at that number. If it's less than or equal to and greater than or equal to, then we will put a closed circle. Keeping this in mind, let's go back and look at this and see how to graph it. X is less than 7, so at 7 we will put an open circle because it is not or equals to. And we will shade left or right. Well, numbers get less going to the left, so just shade to the left. And we put an arrow at the end to show that all those numbers, if we continue on, are also less. Try the next one. We want to get x by itself, just like in an equation. Divide by 2. X is greater than or equal to 5. To graph it, we'll put our numbers that are approximately around 5. Now, this tells us it will be a closed circle. So we'll go to 5, put in a closed circle there, and this is greater than or equal to. And if you go to the right, that's where numbers get greater than, and put an arrow to show that it continues on with all those numbers. All of those would be greater than or equal to 5. The next one, we have negative 3x is less than 9. In this problem, we divide by negative 3. So now we have x, 9 divided by negative 3 is negative 3. Don't forget what it said up here. If you multiply or divide by a negative, you flip the inequality. So this less than will now become greater than. Okay, so let's see, open or closed circle. It looks like it will be an open circle. And greater than, you shade to the right. Now, just like you learn slightly more complicated equations, here's a slightly more complicated inequality. You want to get all your x's on one side and all your y's on the other. We'll start by getting all our x's on one side. And if we subtract the 2, we now have all our numbers or constants on the other side. We subtracted, we did not multiply or divide, so we do not flip the sign. And the numbers in the vicinity of 3. Okay, this appears that it'll be a closed circle, just like we said over here. If it's an or equals, it's closed circle. And less than, shade to the left. The little arrow showing that it continues on. Okay, now we'll take a look at those and or problems. Compound inequalities with and first, which means both inequalities must be true. So what we'll do is we'll solve each of these individually. Divide by 2, x is less than 6, and we'll go over here and solve this one. X is greater than 1. Just marking off our graph. Now I'm going to graph both of these above the line. X is less than 6. It would be an open circle at 6. It would graph to the right. And x is greater than 1. X is greater than 1 would be this. Now, since both of these must be true, the way to look at this is, where are they both true? It's where they overlap. This area here. So it's between 1 and 6. So you would shade this area in between. Also, when they put a problem in this form here where you just have an x in the middle, this is also an and problem. You could actually rewrite this as two separate inequalities. Here we're just going to go ahead and get x by itself in the middle. Now the first step would be to subtract 5. If I subtract 5 there, I have to go over here and subtract 5 and go here and subtract 5. So I now have negative 15 is less than 3x, which is less than or equal to 3. The next step, we just want to get x by itself in the middle. Divide by 3. So what this is saying is x is in between negative 5 and 1. Again, we could write this as two separate inequalities, but this is kind of nice. If you think about that, well, x is between negative 5 and 1. Just mark off our graph. Well, open circle at negative 5, closed circle at 1, and we're saying x is in between, so we shade the area in between. Okay, those are and problems where both must be true, so we look at the overlapping areas to see when both inequalities are true. And this is actually a little bit easier in that they write it as in essentially one large inequality. Now we're going to go to the or problems. X is less than negative 2 and x is greater than 1. I'll graph these two above. The first one is x is less than or equal to negative 2, so that would be a closed circle, and less than would go to the left. Or x is greater than 1, open circle there. Now, again, or just means one of those has to be true. So where is at least one of those true? Well, you can just bring these straight down. And that's how you would graph an OR problem. Okay, you know how to solve equations that look like this, except this has an inequality sign. Let's go ahead and do the next one. Subtract 5, subtract 5. We have 2x is less than 4. So x is less than 2, or subtract 8, subtract 8. X is greater than 1. So we have x is less than 2 or x is greater than 1. In this case, x is less than 2 would be this. X is greater than 1 would be this. Now this is a little bit different. Let's look at this for a minute. Where are at least one of those inequalities true? Well, this one would cover everything from 1 getting greater. This would cover everything from 2 getting less. So at least one of these is true over the entire graph. So that says no matter what number you pick out, at least one of those is going to be true. So we say that as all real numbers. An abbreviation for all real numbers looks like an R with a line like that. All real numbers. All right, that's it for inequalities. Just remember, and both have to be true, or only one of them has to be true. And that's it.